HairMapper, removing hair from portraits using GANs. We present a dataset and a baseline method for removing hair from portrait images using generative adversarial networks. Our core idea is to train a fully connected network HairMapper to find the direction of hair removal in the latent space of style GAN for the training stage. We first demonstrate several hair removal qualitative results of our method. In each image pair, the image at left is the original image with hair, and the image at right is our resulting image. Now we introduce our proposed methodology. Given a real portrait, we first embed it into the latent space using the E4 style GAN encoder. Then we feed the latent code to our proposed HairMapper. We input the edited latent code to style GAN generator, get a no-hair portrait. After that, we utilize an blending method to achieve the final result. The result's hair is removed while preserving facial identity. HairMapper is a fully connected network. Our goal is to train the HairMapper on paired latent codes with or without hair in the training stage so that we can remove hair successfully from any portrait image in the testing stage. The key challenge is how to generate high-quality paired data for training. For males, there exists bald male data in the latent space. But for females, style GAN prevents the sampling of invalid combinations, for example, bald females. Before training, we first perform data preparation. We first randomly sample two latent code datasets D0 and dnoise, and get their hair scores through a hair classifier. Then, we leverage the datasets and hair scores to train a male hair separation boundary. We then use the gender transition results of StyleFlow to train a gender separation boundary. In this section, we introduce the male training pipeline. For male portraits with hair, we edit the latent codes of male portrait hair based on the male hair separation boundary to generate a new portrait without hair. Then diffuse the new portrait with the original portrait to obtain quality paired latent code under the guidance of HairMask. The paired male latent codes are used to train a male HairMapper. The male HairMapper can find the latent path of hair removal for males while preserving facial identity. In this section, we introduce the female training pipeline. We introduce a novel female-male bald pipeline to solve that the sampling of the bald female is invalid in style GAN latent space. We first transform female to male, then remove the hair of the male latent code, get a bald male portrait, then diffuse it with the original female portrait. For the details, please refer to our paper. Finally, we train the final HairMapper on paired data of both males and females. We compare our method with existing image manipulation works based on pathfinding in the style GAN latent space. The demonstrated images show that only our method achieves plausible hair removal. It can completely remove hair from male and female portraits while keeping facial identity unchanged. In contrast, interface GAN changes facial identity. Style space only removes hair on the forehead and has obvious artifacts. Style clip can remove most of the hair, but still causes artifacts in the case of long hair female. Style flow always leads to a smaller head and changes facial identity. Here is another example. In this section, we will demonstrate two applications of our method: digital hair design and single-view face reconstruction. First, hair design can be made easy by successful hair removal, as new hair templates can be directly added to our resulting image. Here we simply perform Poisson editing to blend hair template with the image with no hair. Also, for face reconstruction, our hair removal results can provide clean texture for those methods that suffer from hair at the forehead. We apply GAN fit to portraits after hair removal, resulting in well-reconstructed face with little geometry change, compared with results from the original portraits, but no hair artifact. Now we present more results of our method. We test our method on various images collected from the internet. Experimental results show that our method can deal with portrait images with different gender, age, race, hairstyle, expression, pose, hair occlusion, shadow, and lighting successfully. Thanks for your watching.